Right. So again, good morning, everyone. Thank you all for being here. Welcome to our fourth session of Gensler's Career Discovery Program. Again, this is a series of monthly workshops to spark your curiosity in the world of design and the important role it plays in our society. We hope that through these workshops, we can inspire students to use design as a tool to collaborate and generate positive change. For those of you who have missed previous workshops, you can visit our WHSAD YouTube channel. Today's session is called Digital Design, and I will pass it over to Ms. Anne-Sophie Hall. Thank you. Welcome.
Thank you, Mr. Rodriguez. Welcome again, and we are really super happy again to be here today for this next session. Thank you, Mr. Rodriguez, for all your help in coordinating these sessions, because it wouldn't happen without you. And thank you for the school and the students, obviously. You're the fuel for your interest in welcoming us and to engage in dialogues with you. We always love the Q&A session at the end. I've seen a few of them before, but the three presenters today have not engaged with the students before. So please keep your questions as they present, because these, all the presenters in the past have left those presentations thinking speaking so highly of the school and of the students because of the dialogue afterwards. So don't be shy, and there's no question that is not worth of a question. Today we're going to be, as Mr. Rodriguez was introducing, we've decided to focus the conversation on digital design. And why digital design? Well, number one, because it's a vastly, I would say, evolving area. And everything you're going to be presented today are, tools that we're currently using or tools that we are starting to develop. And by the time you students will be, coming out of school, if you choose design as a profession, you'll be having, created or even used even greater tools. So at this point, it's a field. Digital design is a field that is limitless, quite frankly, and we hope that we kind of demonstrate that to you. So digital design is really, anything that helps us in our design every day and allows us to use digital platforms to really help in the development of our projects. The development of our projects from a documentation point of view, coordination point of view, but also it's all those platforms that are helping us to communicate the design ideas, either within the teams or with the clients. So communication, it's hugely important, and it's part of our roles as designer. And then it's also all those platforms that are helping us better understand our environment, the environment in which we are designing. So, we can harvest data to better understand the environment and therefore create better designs. So today we've selected three design technology specialists in the office. And, they tend to work behind the scenes and help us develop and having those digital platforms, available for us to design. But however, you will see from their presentation that, while they tend to work design behind the scenes, they are hugely instrumental in what we're doing and what the field of design, how the field of design is evolving. And we're really super excited to have them share their passion. So on that, I'll just finish by saying that, Mr. Rodriguez always provides, I believe he's communicated the bios of our three speakers today. Read the bios. I don't want to spend too much, more time from their presentation, but it's always really interesting to see how each presenter we're bringing forward every month has come and chosen a little niche within the design field. And so our three presenters today, Joseph Brennan will start by talking about design visualization. Erika Chan will focus on digital twin. and finally Zach Trattner on intelligent places. All three of them have, from an early stage, or at your age, have had already somewhat decided to go into that field. We're kind of intrigued by that field, and had, on the way, have gone through, gone to school, gone through some professional experience, sometimes construction, which is really interesting, to finally, land where they are right now. And again, helping us develop tools and platforms to help our design. So with that being said, I just want to pass it on to Joe Brennan to start the presentation. Thank you so much. Bye.
Cool. Thank you. Actually, I think Erika, you're going to
Yes.
give us a quick intro. We do a little swapping in the beginning, and then I'll take over. So
Yes.
go for it, Erika.
How can I share my screen?
I think lower right hand, it says
Okay,
present now.
Okay.
Correct.
There you go.
You can choose to present a tab or entire screen.
Okay. Let me know when you guys see it.
Got it.
Yep.
Okay. Hold on. Let me go in presentation mode. Okay. Thank you everyone for having us. It's really great to be here and talk to everyone, and we are looking forward to the conversation afterwards. So whenever you have a question in mind throughout our presentation, please jot it down, and we don't want to miss anything that it pops into your head. So we're excited to listen to your questions after. So let's get started. My name is Erika Chan. I've been at Gensler since 2018. I'm kind of a generalist. I dabble in a lot of different tasks. So my background is in architecture. I've done a little bit of medical planning, and as you guys may know, BIM. So I've done a lot of BIM as well. I am passionate about bridging the gap between the architectural world and the world we live in.
Cool. Yeah, and I'm Joseph Brennan. I've been at Gensler for just over 2 years. I actually started in construction. My family is a long background of general contractors. My father, my grandfather, my aunt's an architect. So my other aunt's a landscape architect. So I've sort of been surrounded by this profession my whole entire life. And I got into architecture actually a little bit later, when I was about 24, 25, when I started actually taking architecture classes. So I came to it a little bit later. I really love the idea of the design process. And I also, I love the way of kind of like improving the way we design and build and working with teams to figure that out.
Thanks, Joe, and thanks everybody for having us. We're really excited to be here and share this presentation with you. I'm Zach. I've been at Gensler since 2018. I'm an architect by training, and I've always been very technically minded as an architect. So I started kind of like Joe in construction, and then I was a roof inspector, got into sports architecture, and I worked on Madison Square Garden, which was an amazing project. But after that, I really pursued my interest in computers and coding, and I ended up kind of focusing on how mobility can be managed by computers and analysis. And I ended up doing a whole bunch of mobility planning before coming to Gensler and working on the digital design team. And this was my focus because I'm really passionate about computational tools. I really think that they're going to transform the way that we design and experience space. So hopefully I'll show you some of the ways that that'll happen later. Thanks, guys.
Thanks.
Cool, great. And while this video plays, I'm just going to tell you a little bit about our design technology team. So the three of us are based in the New York office, but we operate within a larger Northeast regional group that consists of New York, Morristown, Boston, and Toronto. So all in all, there's probably over 1,000 employees or close to 1,000 employees between those four offices. We work closely with them daily, our design technology counterparts in those offices. And we also get the chance to collaborate with other design technology teams in over 50 cities across the globe. The Northeast Design Technology team is very diverse. Our members have backgrounds in architecture, construction, and computer science, just to name a few things. We specialize in a variety of technology-driven practices, a few of which we're going to show you in detail today. We support both specific project needs and office-wide initiatives. So for example, if a team wants to present to a client using virtual reality, we'll work with them to make that happen. We'll also provide ongoing support for larger, more complex projects. So in that case, our involvement is more closely integrated with the project team. We might be working with them for months or even years at a time. So it can be daily tasks, weekly tasks, monthly tasks, yearly tasks. It always varies depending on the project. Gensler's design technology team also creates their own internal software, which we'll show you a little bit of in a few minutes. So when that happens, we would help out with the beta testing of that software and launching that product, which would involve like training offices about it, bug testing, developing curriculum, working directly with the architects and the designers, and holding regular training sessions. Sometimes we do webinars similar to this with hundreds of participants from across the region. As the video shows, we touch on many different aspects of the office and work with many different teams, not just architecture. So we have digital experience design, branding, interior design, consulting. There's a whole bunch of different work streams within Gensler, and we're fortunate enough to be able to kind of work with all of them. That's what I love about our job, is there's never a boring day. I mean, we touch on so many different things and so many different projects that you never get bored, which I love about our roles.
Awesome.
So, as we'll talk a lot about, and I'm sure you guys in your learning a lot of different softwares, maybe like SketchUp and Rhino and possibly Revit and things like that. We work in 3D. That's the way we work as an office now. All of Gensler works this way, and a lot of the industry is trending towards this, or has been trending towards this for quite some time. So what does that mean? We use Revit, which is a BIM software. So BIM and Revit are, it's like Revit is BIM, but not all BIM is Revit. It's one of those things. But it's almost industry standard that when someone says the word BIM, they're talking about Revit, especially for architecture. So BIM stands for Building Information Modeling, for those of you that aren't familiar with this. So it goes beyond just modeling something in 3D. So SketchUp and Rhino are great for quick design studies and modeling things out. But what BIM allows us to do is we generate a 3D model, and from there we can extract a lot of information, some of which you'll see today. We can create 2D drawings, some of those practices you'll see today, but we also can generate a massive amount of data. So all of the elements within our model have data associated with them, and we can do amazing things with those data if we know how to leverage it properly. And we can tie that data into visualization, intelligent places, digital twin. All the things that you're going to see later on today come from these three things that we're extracting from Revit. So here's just this slide's actually a few years old, so there's a lot more platforms we're using now, but we have to deal with a lot of different softwares on a daily basis. And as you can imagine, our office is I think over 5,000 people internationally. They are using different softwares, and they're using the things they're comfortable with, and they have to talk to other platforms, and we have to, everyone has to, in the end of the day, deliver great projects for our clients. So we have to figure out how to work with all these different things and generate visualizations and documentation and models and things like that. So here's just a small example of what we work with. And as you'll see on the next slide, we actually build our own house applications, which is pretty cool.
Yeah, thanks, Joe. At Gensler, we really want to emphasize kind of in-house new strategies and new processes. So one of the ways we do that is developing this tool and the next one this one's called G-Blocks. And in this program, it works with Revit, in which that you have a program from your client and you can lay out a whole massive master plan, as you can see here with all the colors, and it spits out all this data and metrics that we communicate with the client, and we use the 3D views, the plans, and all the drawings to communicate. And this allows us to iterate through design very quickly and very efficiently. Similarly, we have this tool also developed in-house with Gensler called G-Floors. This is more for interior fit outs. So if a client comes to you and says, I want my office to have 10 executive offices and a lot of open work seats. This can allow you to generate a lot of different design options and show all the metrics, the pros and cons. Oh, this one's too dense, this one's too light, and to each design option. So this is a very powerful tool for us to quickly communicate and get down what the client needs. And also with all these tools that Joe just talked about and the tools in-house that we use, even though we generate and we draw a lot of this geometry and models in 3D, we end up at the end of the day kind of outputting only 2D drawings. So the industry now, what the digital design team has realized is that this industry is changing. We're moving past just the 2D, and we're going to be using and integrating more of the 3D to help communicate the design. Okay.
Totally. So yeah, and a major part of that is visualization. So, I think one thing that's important to note is that I'm going to talk about visualization, and Erika's going to talk about digital twin, and Zach's going to talk about intelligent places. But the digital design team, we are very, very multifaceted. So we'll always have to kind of all touch on these different things and also figure out how to tie them all together. So even though we specialize in certain aspects of this, we all kind of have to know a little bit about everything, which is exciting because we can identify opportunities to collaborate and to actually, do new things that are unexpected. So, these are visualization. Traditionally, you would think of renderings or photorealistic renderings, but that has really, really expanded beyond that to a few of the different things that we're going to look at. So the first thing here is photorealistic rendering, which we still do in-house, and these are still very important. This is an airport project. We have a massive aviation division now, and we're working on JFK, LaGuardia, LAX, Pittsburgh Airport, Newark Airport. We have a lot of airport projects going on, and then here we see it, a photorealistic rendering that was generated out of a 3D model that was done in-house. And even though, we'll look at some emerging things like VR, virtual reality, augmented reality, photorealistic renderings are still very important because number one, this really sells the vision to the client, the overall vision. But number two, this is what you would post on a news article, or this is what you would post on Instagram, right? To kind of get people excited about the project. And so we do this for interiors as well, right? And our teams work really, really closely with, our visualization teams work very, very closely with the designers to kind of fill in a lot of these other things like plants hanging from the lights and green walls and digital screens. And what are the people, it's funny, the people that occupy the space, making sure that they look like they would be, employees of that company. So if it's a bank, they might be dressed a little bit more fancily than if it was a startup, so we really try to nail the mood of the environment as well. So it's not just necessarily about architecture, it's also about mood and environment and atmosphere. And then, we can also generate these more conceptual images where it's not, super photoreal, but we can see the context and we can see, these orange people that give a sense of scale and the trees that give a sense of scale. And this is for PMX Sidewalk Labs, which is actually a modular building. So we're doing some really cool work on how to, there's a little bit of a sidebar, but we're doing some really cool work on how to design modular components that can be just installed anywhere across the country or across North America without having to constantly redesign those details. Cool. And so then, one thing that we're really diving into now is, I actually got off a call right before this about using this platform for another project, but we use Unreal Engine or Unity. So you guys may or may not have heard of these companies, but if you've played any video game in the last 25 years, you've used one of their engines. So they for a long time were focused entirely on the gaming industry, but have started to branch out and provide support for the architecture and construction industry. And so here we have an example. This is our office in Midtown, and there's Jeff is using an Xbox controller and just navigating around. In the upper left-hand corner, we have a map that kind of shows you where you are in the space. And you'll notice that the table and chairs are different in each view. We can switch furniture out and we can make it interactive. So a client could go up to a table and click on it and change it, see what it looks like to have a different table and different chairs in the space. Here you'll see an example of augmented reality. So on the right, the user is wearing what's called a HoloLens, which is a Microsoft product, which overlays virtual information onto the physical world. And that's really what augmented reality is. So if any of you have ever played like Pokemon Go or something like that, it's overlaying digital information onto the physical world. And so here she's walking through a construction site, and this is our office as well. And she's seeing what is the ceiling going to look like? What is the furniture going to look like? What are the columns going to look like, right? So she can actually get a sense of the space and the scale of all that stuff within the real physical environment. One other thing we do is like video editing. So it's not just purely generating content, it's also stitching that content together. So this is for Deutsche Bank, which is one of our other big clients we do a lot of work for, and they're rebranding Time Warner Center. And this video was actually their CEO posted it on social media, and it got a lot of traction and got a lot of attention. And we developed this to kind of get people excited about this new space, this new office that they're moving into in Columbus Circle. And one of the other cool things about this is we repurposed a lot of content that we already had. So we had these still renderings, we had a really great Revit model, and Erika and I actually worked with a lot of people on this. And it was, I think, like a week or a week and a half. It was a really tight time frame. But because of all of the work and technology that had gone into it, like the legwork that had gone into it, it was very easy to kind of, I shouldn't say easy, but we could generate this very quickly. And we also have, like I said, video editing teams that storyboard this out, and you can't hear it, but there's music here. We can do voiceover. We do all of this stuff after the fact and stitch it together into one sort of like marketing video. Yeah, and so then animation can also be a tool, right? It's not just for final presentation to clients. It can also be help us to make decisions about the design. So here's an example of a pavilion where on the lower left-hand corner, you see the site plan and you see where the sun is. And then as the sun moves on the right side, or the big image, you see what does it feel like to be in that space during that time of day. So this helps our designers make decisions and say, you know what, it's not bright enough. It's too bright. They can make decisions based on that. But then we can also then present this to the client. So this isn't like a super polished, fancy animation, but it's a really great tool for decision making and design process. Augmented and virtual reality, which we looked at a little bit with the HoloLens, but you can use the HoloLens for this. You can use Oculus. We can have things on a tablet. So in the middle, you can kind of see it in the photo on the screen, but there's a map of Manhattan and Brooklyn and Queens on there, and you hold up the tablet to it, and actually overlaid on the map little points pop up, which show some of our Gensler projects across the city, and you can click on one of those on the tablet and a 3D model of that project pops up. So this is cool for clients, like while they're waiting to maybe talk to somebody, they can hold this up, take a look at some of our work, and it's a really cool experience. We also do product design within our office, so kind of mentioning how our team works with all these divisions of the company. So this is a wall that we actually designed in-house, right? Our product design team in-house designed this, then works with the product manufacturer to actually build it. So where our design technology team stepped in is we built a Revit version of this that designers could go in and adjust and play with the panels and play with the flexibility of it, right? So they could go in and kind of use this as a tool within that product to get the look they want. And then when it's done, they work with the manufacturer and it gets made and it looks exactly like it does in the Revit model. So in the middle, you see a rendering of the model, and then on the right-hand side, what it would look like when you're actually installing it. So last on a couple things on visualization is, everything we've looked at to this point from a visualization standpoint has been kind of digital, but physical representation is also part of visualization, right? So helping to visualize a three-dimensional object. Sometimes you can do that with VR, you can maybe do that with a rendering, but there's no better way to do that than to actually bring it into the physical world. So 3D printing is you know, a major part of that. You know, Basic printer this is becoming more and more accessible, more and more usable. You guys, I don't even know, you guys might have these at your school. If not, I think local libraries have access to these things. And you know, when I was in school, this was brand new, and printers were $40,000, and now printers are $200. So it's becoming more and more accessible. And yeah, it's William said you guys have one. I highly encourage you to take advantage of it and play around with it, because it's such an amazing tool to help visualize things. And you can even show a client, you know, you can print 5 different options of something and just put it on the table, and they love that sort of stuff. So and also for design teams, right? Especially because it's so accessible and it's not expensive. You can just print something just so internally you can make a decision about whether or not you like it or the design team likes it. So the next slide just shows, you know, some places where you can actually do this in the city. It sounds like you guys have one in your building or a couple in your building, so that's great. You don't even have to travel. But yeah, this is becoming more and more accessible. And they even have some online resources like, I forget some of them. I can maybe try to find the names, where you can just send them a 3D model, and a couple days later in the mail, they'll ship you the object for relatively inexpensive. So yeah, it's a really cool technology, and it's kind of the future of translating three-dimensional digital information into physical information.
Awesome. Thank you, Joe.
Sure.
Okay. Hi, guys, again. For our next topic, we're going to talk about what is called digital twin. And so what is digital twin? Well, let me give you an example of the first digital twin, or something similar to it. Years and years ago, on the left side, you see this image you may recognize as Apollo 13. And on the right side, you see kind of like an indoor space with these huge kind of machinery. And so what this is a physical twin of the actual spaceship that was launched. So the idea is that you have an identical replica, that if Apollo 13 had any issues or any technical breakdown, that they could send back to this facility that the same issue, and they could try to regenerate the issue and resolve it and send back the resolution. So this is the first example of digital twin. And so how this ties into our architecture business is through what is called digital twin. So what does that really mean? It's bridging that physical world and our digital world together. So on the physical side, you have the built environment, you have a physical, tangible object that you can touch and feel. So that can range from buildings to kind of furniture, and I'll give some examples of that. And then digital side would be how it looks in the virtual world online, and what is called IoT, which we will also talk about. So there's a direct link between the two. And so an example of some objects that you may see at home of a digital twin would be, firstly, these physical objects in real space would be this kind of Nest thermostat that you may have around your house. And what this does, this is a physical object that is connected to the internet, that is connected online to an online thermostat, essentially, where if all of these rooms, for example, have each their own thermostat, they all go to this online platform where it can monitor each room about how hot or how cold, if it needs more ventilation, stuff like that. All of that is kind of tabulated down on some sort of dashboard. And in this example, is showing only a floor, but imagine if this can be scaled up to a whole building, that this small item, this physical item and digital item, can translate into monitoring a whole building, which will impact our output of energy, output of air conditioning, to better help our environmental impact for 2030. So that's one use for it. Another uses that we've used at Gensler is the BIM models, the Revit models that we build, it can be generated onto some sort of platform that we see the whole city, that we know which building has what. And so there are, as you can see in this list, there are a whole bunch of different kinds of twins that, you know, we can dive into. For example, one of them would be in this image on the right side. Is this person is holding up an iPad in front of a piece of machinery, and you can see highlighted on the iPad that these objects are highlighted green or red, meaning that this person got a notification to come down and fix this, and it tells you how to fix it. And so once they do fix it, they can log it in and say, this piece of machinery is up to date, it should be functioning as planned. And so that can really impact a whole system in an entire, you know, something like a tower skyscraper. And so finally, I talked about what we use the BIM model for. We usually use it for design and construction operations, but then there's a whole nother side to it. What do we use with all the data? We use it for machine learning, AI, computing, and Internet of Things, otherwise known as IoT. So what is IoT? IoT, Internet of Things, is using commercially available sensors to understand how people use space. So for example, on the right side, we see kind of these trash bins at different levels of fullness, I guess. So this one at 95%, if there's a sensor in it, it can sense that it's almost full and that it can trigger a warning to the trash collectors to come and pick it up. So this is creating a sense of efficiency, so that it's not that the trash collectors are coming by every day and looking in your bin and there's nothing there. It's only when it's full that, you know, they come, and it saves time and money. So another example of IoT that is also in your home would be the Amazon Alexa. So you may have it that your Alexa is hooked up to maybe your Amazon account, that if you're low on toilet paper, it knows that, oh, I only have 2 more rolls left, so I should probably order more, and so it'll be at your doorstep very soon. So that's another idea of Internet of Things. And then Internet of Things also ties into what is called open data. So this is when all these public organizations input their IoT or their data into a whole database. So things that it can be used for buildings that we talked about, demographics, commerce, but also road networks, meaning, let's say, Google Maps, the traffic conditions, all of those kind of feed into these platforms. And so here's an example of someone took the open data and used a simple Python or coding to create this data visualization map that you see here of Manhattan and you know, Brooklyn, that the taxi trips, and you can see very clearly that the taxi trips off obviously kind of are very clustered in Manhattan. So this is just a visual impact of what data can do and tells a story. Another story here is an example of all the different tree species laid out in New York. So you can see that, you know, more reds are down here, there's more greens, and so it's telling a story. It's, you know, all this information can help you impact design. And so here's a link that we also have at the end of the presentation of how to start accessing this open data and how to start playing with it.
Thank you very much, Erika. Okay, so I'm going to talk to you guys about intelligent places, which is a new practice area that we've started in the Gensler, New York office. So we're actually a pretty small team right now, but it's all people who are very passionate about computational tools. And we all think that the future of design is going to be largely driven by computation. So what are we actually doing there? Well, we use computational methods and new technologies to drive innovation, produce insights, and develop client-facing tools. And so it's a really interesting profile of work, and you might be asking like, well, why is Gensler investing in this? It's not traditional architecture. It's not like design. Could you go to the next slide, please? Yep. So Gensler is interested in intelligent places because philosophically, we're a firm of placemakers. We take it very seriously that our portfolio of work is huge. We impact a lot of people's lives. And so it's really important to us that we make places that are beneficial and meaningful for people. So since technology is increasingly impacting our lives and our experience of place, we think that intelligent places is going to be well positioned to kind of steer how that transformation takes place. Kind of in the way that advanced computational tools used to be about, cool geometries and stuff. We think that there's a lot more to it. There's like data and analytics. And that's what, one of the big advantages of having these sort of powerful computers and tools is going to be. So a few examples of, how we can affect projects is kind of early on at the beginning phases of a project. There's a lot of analysis that takes place. And these are some types of analysis that are pretty well understood and well accepted. We do this on almost every job now, like Joe was talking about before. We do solar analysis. That's something that's been done since ancient history, right? But we can do it a lot faster now. And we can, see where the shadows are going to be, how much solar heat gain an office space might have. Do we need to do something about it? We can also do wind analysis, and that takes a lot more computational power. It's something called CFD, fluid dynamics. So, it's really complex stuff. We usually hire engineers to do that, but we can do some of the simpler analysis ourselves. And that'll identify things like, oh, is there going to be a wind tunnel here? That sort of question. And then we can analyze views too. And that's kind of like if I'm sitting here in my room and I look around, I can see a certain number of things in my field of view. So if I was looking out a window, I can see further, but like I'll see what landmarks and buildings and stuff I will have in my view for an unbuilt building. So this is a really great analysis tool. But that's all the stuff that's like pretty well accepted today. So, and we do that work as the digital design team. But there's a whole other set of analysis that Intelligent Places is experimenting with that we think are going to be equally important. So a couple examples here are behavioral analysis. So we look at things like how people will move through an unbuilt space and how they'll occupy it. And like a couple examples here are we can see, well, what if I spaced people out by 6 feet or 9 feet? How many people could I fit on my floor? And then, will that affect how people circulate through the space if I have, 10 conference rooms instead of 5 and like 50 open desks instead of like 20 closed offices? And so we can really analyze that and give our clients a picture of what it's going to look like and how it's going to be used before it's built. And one of the tools that we developed at Intelligent Places is called Graph. And that's like a service offering that includes those behavioral analyses I was just talking about. And we're really excited about this tool. It's been a huge success so far. We've sold millions of square feet of graph analysis. And this was a great project. Like we worked with branding as well. They decided what to call it. They worked on the logo. We've worked with the lawyers on this. This has been a huge interdisciplinary project, and we're really excited to see where it's going to go next. So how does Graph work? Well, I can give you a little bit of information. So it does use Revit. We build these Revit models as design teams, and then the Intelligent Places group and the Graph team kind of absorbs that model, does what we need to do. We might add a little bit more data here, make sure that the circulation is going to work well there. And then we export that model, do some analysis on it. We simplify it as much as possible. And then we sort of turn it into a database. We like do a whole bunch of computational processing on it and turn it into a database that we can start asking questions of. Like, if I do this, will this happen? How will people move differently? That sort of thing. And so then we take that analysis, make it look great, put in a report, and present it to our clients. And it's been really successful so far. Here's another example of sort of advanced computational analysis. This is more like what I was doing before joining Gensler at an urban scale, but it's also really interesting and something very powerful that computers can do for us. So this is like a travel time analysis. So you can kind of think of it as Google Maps. You know how you have a start point and an end point, and it'll tell you, oh, if you drive, it'll take this long. If you take transit, it'll take that long. You can do that, but like 10,000 times over. And then you get this picture out of that analysis that will show you really quickly, like, oh, well, if I put a subway station here, I'll have a huge impact for all of these people in reducing their travel time. And so it's a really useful tool that we have as well at the urban scale of analysis. Now, another thing that Gensler does in intelligent places, and not just intelligent places, like we are an experience-focused firm. Gensler cares a lot about the users of our space and our clients and how positive their experience is going to be in our environments. So one of the tools that we have there are surveys and statistical analysis. So what we do in intelligent places is try and find new and exciting ways of making surveys more interesting and using things like metadata to get more layers of information out of those surveys. And then we can actually run statistical analysis with like really cutting edge tools, the sort of things that Google and Amazon use. And it ends up being a really powerful tool in our arsenal at like early stages of the project to understand our clients' needs better and really answer the questions of design. And it's a lot of fun too, because we get to work not just with architects on this. We work with statisticians, we work with app developers, behavioral psychologists, you name it. There's a role for everybody in this kind of work. So what do you do when you've got all of that survey data, all of this spatial data from graph and things like that? Well, that gives us an opportunity to start doing machine learning on our big data sets. This is something that has been affecting our lives in other areas, like not so much the built environment, but like Erika was saying, Amazon knows what you need before you know what you need. Or, your social media can connect you to people that you already know, but you didn't have them like on your friends list already. So, we're trying to apply that sort of philosophy to the built environment. And it's a really exciting area. There's a lot of change happening right now. And another advantage here is that you can scale your impact exponentially. So a small team can make a huge impact with big data and machine learning. One of the other services that Intelligent Places offers is living labs. You may have heard the term before. It's kind of been a buzzword for a few years. And our clients are actually coming to us asking, like, can we do this with you? And the answer was, of course, yes. So what we do here is we'll design a space. We'll observe how people interact with and use that space. We'll do things like, surveys, following people around and entering data, stuff like that. Then we'll make a change and observe what happens after the change. So that way you can see like very scientifically what happens when you go from A to B, and that'll help inform future projects too. So one example of a living lab that we did was in this flagship retail store in New York. So this client came to us because they were renovating their space, and they wanted to see what would happen before and after they, changed what product was where, a few architectural changes, nothing enormous, because like with a living lab, you have to have it be largely similar to have the effects be meaningful, like the difference between the two things. And we learned some amazing things from this study. So we followed around a whole bunch of shoppers, entered where they went into the store, recorded their experiences, and we learned, for example, group shoppers are 3 times more likely to make a purchase than individuals. We also learned things like if a store is too open, you lose that opportunity for spontaneous discoveries, for unexpected moments. And people really like that in a flagship retail environment. So, these are the kind of insights that the tools that we're developing let us make, and it'll impact, our clients and our projects today, but also going forward into the future. So one of the tools that we use to do these sort of living labs is sensors. And like Erika was discussing before, there's all sorts of commercially available sensors. One example is an occupancy sensor. So these are pretty common. They're in a lot of places. You can kind of think of it like if you have a light in front of your house that's motion activated, if you walk in front of it and it goes on, that's an occupancy sensor. And that's one type of data. We also do things like desk sensors. So you can actually tell if a person is sitting at a desk. And we did that in our own office. We put desk sensors in to make this hoteling system work. Of course, this was before COVID, that you would be sharing desks with other people. So we're gonna, look at how that's gonna change in the future, of course. But these are the sorts of things that we can do. And we also actually don't just use commercially available sensors, we build our own sensors too. So how do we do that? Well, we use something called physical computing. So there are a few providers of this technology out there. For example, Arduino, Adafruit, Raspberry Pi. And what these platforms do is they integrate hardware, like that little computer you see on the screen. It's only about that big. Software, like they have a development environment, and content that's produced by a very large and active community of makers. Like this is a very exciting way to start experimenting in the area of like coding and computing and stuff like that. And things like Adafruit are great for wearables, which is really exciting and a fun way to design stuff. So here's a few examples of things that you can do with Arduinos. There's this robot that was developed by an architecture firm where you put colored markers in it, you hook it up on a wall, program in your image, and then it'll draw that image on the wall with markers. So it's pretty cool. A much simpler example could be this LED clock. Like that's something that an amateur like me, or probably even you guys with a little bit of work, could make. And then wearables too. So glowing clothing, clothing that can hear music and then respond and like act in different ways. So it's a lot of fun. And then if you're interested in experimenting with Arduino, it's pretty accessible. It's a relatively simple coding interface, and it's really responsive too. So you can, tell that little LED there to blink every second and press play, and then it'll immediately show you what the results of your coding did. And you can layer things in like 3D printers, laser cutters to make more complex projects. And then, yeah, one of the great pieces of technology that we've developed in-house in Intelligent Places is this specialized sensor and the technology that's loaded onto the sensor, where you can use a camera to see where people are moving around a space, and then it uses computer vision to identify the person and their shape and like where they are in the space, and then you can start using that data to do all sorts of really interesting and exciting things. And so, this was another thing that we did in our office too. So, it's a lot of fun to work with physical computing, and it's a really powerful tool. And with that, I think we're going to take some questions.
Thank you so much, Joe, Eric, and Zach. It was so great. It was amazing, super inspiring. So we're turning it over to the students. Do we have a master of ceremony for the questions? I know that
Can you hear me?
usually. Yes, yes.
Yes, we have you.
Yeah, I'm gonna be your moderator today.
Perfect.
So if people could start putting the questions in the chat, and then I'll just repeat them out for you guys. Can you hear me?
Yes.
Yeah. Okay. My question is, how do you deal with data and privacy when designing a space?
Good question.
Good question.
Definitely. So that's something that has become more and more of an issue in recent years. I don't know if you've seen the whole continent of Europe now has a data privacy standard called the GDPR. So that kind of means that any work that you do that could potentially interact with somebody in Europe, you have to follow these very strict standards. And California also has some pretty strict standards. So, you know, we're trying to be as respectful as possible with people's data, because like not only are there legal questions, there's moral questions too. And you know, as a firm that cares about people, we want to be on the side of you know, treating people respectfully. So to do that, we use a lot of things like anonymized data or waivers, like in the cases where you can't have anonymized data. So that's how you can kind of build up a database of meaningful information, like what people do, where they go, without actually knowing anything about who that individual person is.
Okay, thank you. Kevin Garcia has a question. He had his hand raised.
Yeah, I have a question. How do you guys maintain a healthy relationship with companies like Turner, JB&B, GMC, and Cerami?
That's a good question. Should I tackle that? We're so big that they can't not be nice to us. No, I'm just kidding. Kind of. No, but it's actually really an interesting question. And there's two things. It comes down to relationships, right? So, you know, our team is really has good relationships with a lot of the BIM leaders and the design technology leaders at those companies, because we deal with them a lot and we're used to how they work. And, you know, it has to be, I find when it's very collaborative, it works well, you know? So we ask them for suggestions on things, and we provide suggestions to them. So that's one way. You know, like pretty much every company you mentioned, I'm working on a project with right now. And so I talk to those guys, like at Cerami, the BIM leader at Cerami, I talk to him once a week. So it's about the relationships, but it's also, honestly, a lot of it is about contracts and being very diligent about that, and you know, and making sure that things are spelled out right, that you're holding to the letter of the contract, expectations are all aligned. Because I think what ends up happening, problems arise when somebody asks for something that maybe is not in the contract, and then it starts to become something that's beyond what we were asked to do. And it can, you know, on a million square foot project, that can be a lot of time. You know, on a 10,000 square foot project, maybe it's a couple hours. And so we have to just be careful that we're, you know, and if they need us to do something different or need us to do something extra, we talk to them about it and sort of come up with an agreement. But and our design technology team actually ends up getting involved in a lot of those conversations because of like us understanding the effort of what it takes to create a digital twin, for example. Like if they, you know, what Erika presented about digital twin, if somebody came to us and asked us to do that, it's actually a tremendous amount of work outside of what we would typically do for a design project. So we would work with the project team or the design manager, whoever's writing the contract, and we would help to determine how much extra work that is. So, you know, where it could become a challenge is if that gets missed or nobody really understands how much work that is. So that's why I think honestly, communication and relationships are really the most critical part of that, both within Gensler with our teams and also externally. Yeah.
Thank you.
Sure.
All right, next we have Myra Gomez. She asked, how can BIM modeling improve the infrastructure of the building?
Do you want me to go again? Okay, so basically, the thing that's great about BIM, and the way I sort of describe it to people that maybe are in architecture savvy or in construction, is we are basically building the building in the computer before we're building it on site. So to your question, and one of the anecdotes that we say a lot is it's a lot cheaper to fix on paper than it is to fix in the field. Or, you know, it's a lot cheaper to fix in a 3D model than it is to fix on site. So if somebody puts a steel beam in and there's a ductwork that's supposed to go there, that's a very expensive issue once it's installed. It's probably a couple hours of work to solve in a 3D model, and it's probably a couple weeks of work to solve in the field. So the more detailed our models are, the better we can coordinate the infrastructure on the projects, and the better we can understand the conflicts. And as much as we can resolve them, you know, it might cost a little bit more to do it in the computer, but it's substantially less money than it would cost to fix in the field. And so even kind of going further, that's from a coordination standpoint, but you could actually run an analysis on a mechanical system that was modeled in 3D. You can understand how efficiently it's performed. You can understand the loads. You can, you know, they run energy models now where they compare the solar gains of the building versus the mechanical systems versus the facade and the glass efficiency. And they understand how the building functions as a whole, right? And that's all done before anyone even, you know, starts to build something. So there's, as long as these models are done well, and people know what the end result is for and what you're trying to get at, we can do so much in BIM prior to even touching a hammer or a shovel. So yeah.
Yeah, just one thing. I love the way the question is phrased, number one, because it says, you know, how can BIM modeling improve? And that's a very good point. And I think Joe's response was equally good in the sense that he really highlighted the fact that all these tools at the end of the day are really here to better our field, right? Our design field, and equip us in, you know, in better ways that are, you know, allowing for efficiencies and less cost and so on and so forth. So that's really the ultimate goal. And that's when it's, you know, it's really satisfying, I guess, for this team here to really be part of the process.
Totally.
Thank you. Next, William Cordova, he asked, what type of programs would you suggest we focus on to get started in this field?
I guess I could weigh in on this. So I've got a professor in my past who I asked that exact same question of, and his response was, you know, the best thing you can do is to learn to code. And if that interests you, there's no time to start like the present. You can think of coding like learning a language. And, you know, you guys are young people. You're much better suited to learning languages when you're younger. Believe me, it gets much harder as you get older. But also, you know, coding doesn't always have to be like typing out computer language, although that is a really great way to do it. In that case, I totally recommend something like the Arduino, like the kit that you've got on screen here. That's an amazing way to get started with coding. But there are also tools that are much more accessible to a pretty much broader group of designers. Things like Grasshopper, where it's like a visual programming language, and it's the same thing as coding, but it's done much more graphically. So like this function impacts the next function, impacts the thing after that, and you get something out of the other end. It's all the same principle, and it's really important to learn how to think computationally. That's something that we always come back to, and it's a skill that you guys can learn, and it takes time to do it, but it's well worthwhile, I think. There's a lot of work to do in this area, and it's really exciting. And so the more people that we have that are like excited about it, the better.
I agree with Zach. The coding is the way to accessing all this data and having it make sense. And kind of adding on top would be, there's really easy ways to start to learn how to code. Is, you can download apps on your phone and do 5-minute exercises, daily. So I started that. I started a little bit too late trying to learn how to code. I started probably after college. But so it was a little harder, but I downloaded the app and it started clicking. It started making sense. And now, I'm an amateur, no comparison to Zach, but, it's never too late. And the earlier you start, the better.
Erika, you're great. Don't worry.
I would also just add one last thing, which is that you should really use the tool which is going to help you realize the design the best. So there are limitations and restrictions on every program. So like Revit is really good for documentation and data and schedules and drawing sets and all that stuff. But curvy, complex geometry, really quick design studies, it's not good for that. Whereas SketchUp and Rhino are great for that, but they are terrible for documentation and for like sort of bringing it to a contractor. So I would say being able to identify this is a bad answer to the question probably, but it might be a 3D print. It might be a chipboard model. Whatever is going to be the best method for you to realize your design, I think is the most powerful thing. And so I would say try to find something that you're comfortable with and gives you a lot of flexibility and versatility, and use that, and then also figure out how that program can connect to other programs. Yeah.
Okay, thank you. Next is Raven saying, have you had any challenges with using Bim?
Challenges using BIM. Yes. To put it short, yes. It's hard. It's difficult. It's a lot of tedious work, but it's worthwhile in the end because I guess the way I think about it is when you do BIM, you get out what you put in, right? If you put in good data, you'll get out good data. So it's just about that consistent effort, and it does pay off in the end. It's hard to get other people to see the same way you're thinking. So it's about not convincing them, but trying to make it easier and trying to get down to their level and speak like, okay, if you don't have time to put in all this kind of information manually, what can we do as digital designers to help you quickly make a script and input that data, automatically. So it's about communication. Yeah.
Next is William Cordova saying, do you have to model every item using BIM?
Well, okay, maybe someone else can add too, but there is a thing called LOD, and that means level of detail, and that applies to 3D models, right? So most of the models that we do will be mostly floors, walls, doors, windows, roofs, stuff like that. But when we get into more of the interior design stuff, people like to see the cabinetry, all the little handles, but then there's another level and that depending on your client and the visualization, right? They want to see all the little knickknacks, all the little spoons and bowls on the table to make it more realistic. So it really depends on your audience and how you're catering to them. So the answer to your question is it depends.
That's totally right. And we start every project with the best intentions of like, oh, we're going to model really well here, and then deadlines happen, and then at the last minute you've like got to print your drawing set and get it to the DOB to get approved, and then you end up just like drawing stuff in 2D. So like Erika was saying, it depends on what the purpose of what you're doing is. So if it's, drawings that need approval, at the end of the day, it's a 2D document. But if it's a 3D rendering, like Joe, I'm sure, can speak to, you really do have to model quite a lot of information.
Yeah, and the one thing I would add is kind of going back to the previous question is that, at Gensler, everything goes into Revit and then goes to documentation. But that doesn't mean every single element has to be modeled directly in Revit. So, all the walls, doors, windows, curtain walls, all that stuff is very, easy. Not, I don't want to say easy, but Revit's great at doing that stuff. But if I wanted to do a really, really intricate, detailed staircase and I needed to show it in my drawings and I needed to render it and all that, it might be very, very time consuming or maybe not even possible to do in Revit natively. So you might have to work in Rhino or SketchUp or something and then bring it in. But you have to be smart about how you do that. You have to think about it. You have to think about how am I going to model this in a way that I can bring it in. So it's kind of an open-ended question. So it really depends. But one thing that is, as Erika had mentioned, the LOD, we do LOD 300, and this is getting like really, really sort of into the details. But once you go beyond that, like LOD 350, LOD 400, LOD stands for level of detail or level of development. That's fabrication modeling. So those are contractors and mechanical contractors and facade contractors are modeling even more detailed elements because they have to actually fabricate it and build it. So they might take our model and bring it further. And so depending on the phase of the project and who's actually doing it, different things need to be modeled. Or, if they have one joint that gets repeated 500 times, they may model it really detailed once and then know that that's the same joint 500 other places. So it needs to be a little strategic. Yeah.
Thank you. Megan Golden says, do you see digital design as an emerging career? And if so, what pathways are there besides going to college?
Definitely, yes. Digital design is a really exciting emerging career. I think that even 10 years ago, it would have been understood that someone who was interested in digital design would have been like a support person there to help other designers, negotiate the technology and produce design. Now, we find that digital design is so much more. Like this whole presentation's just shown example after example. We're visualizing things. We're helping designers. We're doing advanced analysis and really steering how the design goes. And so that's it's a lot of exciting work and it's a lot of challenging work. But like the way I see it is we have to stay on the cutting edge because your generation is going to be coming for our jobs next. So there's a lot of stuff to learn here, and it's going to be interesting. And if you're passionate about it, if you're interested in it, find whatever path interests you the most and just pursue it because there's so much to learn. It's so broad. And if you're doing something that interests you, that's going to be the best way for you to learn.
Totally. And I think I would also add is that, we want all of you guys to eventually come work for Gensler, but you could go work for a startup that's doing this stuff, that's in the design technology space. There are lots of companies out there doing urbanism that are doing construction technology, architectural technology, real estate development. There are lots of things that design technology ties into just outside of like architectural practice. So, Google has developments that are focusing on this. There's lots of opportunities out there for people that are interested in design and construction or real estate development, but don't necessarily maybe want to focus in a traditional path.
Thank you. To continue, she said, do you recommend any schools in the NYC area for design?
It's a good question. For design technology, a lot of the major universities in the area have great programs for that.
Right.
I know City College Technology has a really good architectural technology program that I actually did some robotics work with once. They had like they have a robotics program. I don't know if they still do, but that was a few years ago. But there's even, I mean, you know, there's Pratt, Columbia, City College has a great program. CUNY and City College. But then there's also Stevens Institute in Hoboken, which actually a lot of people that I worked with early in my career in construction technology came from, and they do a lot of work with like fabrication and manufacturing and things like that. So you learn a little bit more if you're really into the detailed 3D modeling and things like that. They have a great program for that too. So there's a lot of great places within a train's ride of Williamsburg that you guys have access to.
All right, thank you. And for our last question, we have Daryl saying, do you think design will become more futuristic in the near future? Will be helpful?
Yeah, I guess I can say that, you know, there's so much change happening so quickly now, and you know, it's really hard to keep up with all the research of like what people are doing and where things are heading. So for example, you know, now there are little robots that go around the sidewalk delivering packages. You know, there's all these questions about, well, how are these robots going to affect people? Like, are they going to share the sidewalk with us? You know, that's just one example of how technology is changing our world, and we as designers have to respond to that. I don't know if that answers the question at all, but you know, it's something to think about.
Thank you. So on behalf of all of us today, we'd like to say thank you for taking time to present to all of us. It was a really great presentation, and we definitely all benefited from it. So thank you.
Great.
Thank you so much.
Thank you.
Thank you all once again. Another great one.
The bar is getting higher and higher.
Yes, indeed. Yes, indeed.
The challenge is on. Thank you so much, all
Thank
of you,
you.
for the great engagement, and we'll see you in a month.
Have a great one, everyone.
Bye. Thank you all.
Thank you so
Bye.
much. Bye-bye.
Thank you very much. Bye.